Hello guys, welcome to Ramta Solutions and welcome to lesson on grade 12's work, energy and power. Today in our past paper series, we are looking at a paper from Limpopo province written in September 2023. Okay, so without any waste of time, the statement of this question says, a pulley system with a mesh piece is operated by an electric motor. Oh wow, electric motor, interesting. It is used to lift a load of 100 kilograms vertically upwards at a constant speed. Do you hear this? At a constant speed, as shown in the diagram below. The load covers a distance of 6.8 meters in 0.01 seconds. Neglect all the effects of friction. 5.1. Define the term power as applied in physics for 2 marks. So in physics, 5.1, let me use a red color, or black, not red. 5.1, we define power as, how do we define power? We say power is the rate at which work is done, isn't it? Is the rate at which work is done. Right, is the rate at which work is done for 2 marks. Okay, I believe there's a 5.2. Let's go back. Now, calculate the work done by the gravitational force on the load. Did you get that? The work done by the gravitational force on the load. Okay, so a question that you should ask yourself, what is the load? You can see that the load is going up. As it's going up, it means the work done by the gravitational force will be basically calculating the weight. So it'll be negative work. So what we know that work is equal to, here we're looking at, what was the question? It said of the gravitational force. So let's call it, let's call it work done by gravity. So I'm going to use W F sub G or W sub F sub G. So Fg delta, it's going vertically, so it's delta y cos theta, okay? Cos theta. So now, what is Fg? You and I know that Fg is basically, we know that F sub G is basically mg. This is the weight, isn't it? So allow me to just call it weight delta y cos theta. Is that okay, guys? Cool. So, what is the mass of the weight? The mass of the weight is 125 kilograms. And what is the distance covered? It was 6.8 meters. Okay, so it's 125 kilograms. We know gravitational acceleration constant is 9.8. And they said the distance moved is 6.8. Now, we said weight is opposite the motion of this load. So it'll be 180 degrees. Okay, it'll be 180 degrees. So our answer, quickly taking out our calculators, we have 125 times 9.8 times 6.8 cos 180. Okay, so what is our answer? Our answer is it's negative 8,330 joules. Okay. This is the work done by gravity. So as you can see, this means gravity does negative work on the load. Okay, perfect. Now, 5.3, determine the average power output required by the electric motor to lift the load through 6.8 meters in 0.01 seconds. So to do this, first thing first, we need to know the work done by, the mesh piece, okay? Or in other words, not the mesh piece, but rather we need to know the work done by the electric motor. Because yes, the electric motor is not shown here, but we need to know what it is, okay? So, what we know, the electric motor, remember, is used to lift a load of 120 kilograms vertically upward. This is what its function is, okay? So we therefore need to say we will use work energy theorem. Rather, for now, I prefer work energy theorem, which says net work is equal to change in kinetic energy. So net work, what are we looking for? We're looking at the work done by, look, I'm going to write motor, okay? Plus work done by, let's say, what is it? It was the mass piece. So I know it's not going to be nice to have such a long wait. And the work done by, what is it? And the work done by the load, isn't it? And the work done by the load, right, are all equal to, now, before saying this, remember, they said at a constant speed, right? Let me use a highlighter, rather. At a constant speed, right? At a constant speed, right? At a constant speed, where is it? At a constant speed, okay? At a constant speed. So a constant speed tells us that change in kinetic energy is 0, isn't it? So we will say, okay, work done by the motor, I'm going to leave it as it is, plus work done by, what is this? The mass piece. What we know that we don't have the force, but we have what we call its weight. So it'll be mg delta y cos theta plus work done by the load. Work done by the load, which is the weight. It's basically, we'll say it should be that negative 8,330 equals 0. Okay? It will be that. Okay? And now what we now need to look at is this. What we know, oh, by the way, guys, how you got to this calculation is by drawing a free body diagram on the whole system. Okay? The whole system means you're including the motor, you're including the mass piece and the load as well. Right? And the load as well. Okay? Perfect. So, now, let's go now. What do we do? We know that mass of the mass piece is, what is it? It's 100 kilograms, okay? So let's go. Work done by the motor plus work done, mass of the mass piece is 100, gravity is 9.8, distance traveled was 6.8, right? It was 6.8, isn't it? It was 6.8. So we will say, what does it do? Does it do positive work? Should we say it does positive work? Yes, it does positive work. So I'm going to say cos 0 degrees minus 8,330 equals 0. Okay. Proceeding, we have 100 times 9.8 times 6.8. What is it? It is 664, right? So work done by the motor plus 6,664 minus 8,330 equals that. So this answer minus 8,330, I won't be rushing it, so it will be work done by the motor minus 1,666 is equal to 0. Therefore, work done by the motor is equal to 1,666 joules. Okay, so the motor does positive work as well. Okay, the motor does positive work as well. Okay. Now, what we are now looking at, or what we're going to look at now, is this. We have not yet answered the question. So, the definition of work, we said it is the rate at which work is done. Okay? So we can say this is, by the way, power equals work over time, isn't it? So what is this? This is 1,666 over, what is the time? They said it was 0.01, I believe. 0.01. Let me confirm. Remember, this portion here said the load covers a distance of 6.8 meters in 0.01 seconds, isn't it? In 0.01 seconds. So cool. So that answer divided by 0.01, what is it? So we find that the work, not the work done, the power, right? Yes, it says the power. The power output is 166,600 watts. Okay, so this is the power output of the motor. Okay, this is the power output of the motor. All right, guys. So yes, this is it, guys. This is how we attempt our questions. Okay, this is how we attempt our questions. Right. And I hope you guys will be acing this topic in your exams. So remember, if you want to contact us, you can check us out on our website, ramtasolutions.co.za. And from here, you are also able to, you can send us an email if you need anything. And you can also chat to us via WhatsApp. Okay. You can also chat to us via WhatsApp. Okay. By the way, there's an exciting blog post on our website. And trust me, you will enjoy reading the blog post we have there. We have articles talking of work, energy, and power, maths articles. So it's exciting, guys. So check the website out, okay? So, with that being said, it's a wrap and bye-bye.